Hey, what's up, guys? This is Sean here. So today's daily challenge problem number 473: matchsticks to square. Okay, so you're given like an integer array matchsticks where uh, each element is the length of that matchstick, and we want to use all the matchsticks to make a square. Okay, and so there are some rules. Basically, obviously, you cannot break any stick. Right? Basically, if that stick is too long and you cannot break it, but you can link the smaller sticks together, and you must use each stick exactly one time. So which means that you cannot reuse a stick, and you cannot uh, have some sticks that has not been used, right? And you just need to return true if you can make a square, otherwise false, right? So for example, right, we have this kind of 5 matchsticks, right? So the answer is true because uh, this is a square. So this is a square with a size size 2, right? So this is 2, this is 2, this is 2, but this is a 1 1, right? So that's why this one is okay. And example 2 here, this one is not, it's not okay. That's why we return false. Okay, and there are some constraints, right? So the matchstick is only it's about 15 matchsticks in total, and each one is like 10 to the power of 9, right? So I mean, so when we see this kind of a matchstick, right? So this one will give us like a hint that we can. So the time complexity for this problem should be somewhere between 2 to the power of n, right? Because this one can be represented by a bit mask. And so at the beginning, I was thinking that, can we find like a greedy approach? Like if we can sort this sticks from the longest to the shortest, should we try to use the longest sticks first, right? But after some times, if I realize that it seems like there's no greedy approach, Otherwise, if there's a greedy approach, the constraints, right, will be somewhere between 10 to the power of 5 instead of 15, right? Because if we can solve this problem in the greedy approach, this is going to be either n or log n, n log n time complexity, right? And and it actually it's true because we cannot simply assume if we should always use the longer sticks matchstick first. Basically, the greedy approach will not lead us to a correct result, right? So then it leave us no options but to try all the possible combinations, right? But if we simply try all the possible combinations, right? I mean, it'll TLE even with this kind of 15 matchsticks. So the next question is that how can we identify, is there like a state, right, where we can uniquely identify it that can give us like a fixed result? I mean, if that's the case, right, and then we can use DP or like top down with memorization, so that we can reduce the overhead, right? Basically, we can start at the beginning, at the very beginning state. We can break down this problem into some sub problems, as long as that state can be uniquely identified, right? So now the problem is that what's going to be that state? Basically, it's the state of DP, right? So the first thing is that, of course, is that what are the matchsticks are currently available, right? So which means we can use a bit mask. So that's going to be the first state, right? And so with that bit mask, right? So what's going to be the second state? It's going to be that basically how many sides, right? So how many sides we have already formed, right? And then the last one is what? The last one is the remaining. It's the remaining. Basically, this is the current side we're working. This is the side we're currently working on, which means that let's say we have already finished 2 sides, which means we have already have like 2 sides completed. Now the remaining is, let's say, is 3. So let's say the one thing is that given like the total matchsticks, we can easily calculate the target, basically the length of each side, right? So we just do a total and then divide it by 4. And assuming we have a target here, right? Target of each side. Let's say this one is 10. So with this 2 and 3, it means that we have already formed 2 sides, and now we're working on. Sorry, this one, I think in my case it is there are 2 sides remaining, and here is also remaining, which means that we are the target is 10. We have already have 3 on the current side, and which means we have 7 to go. Okay, so basically with these 3 variables, we can uniquely identify this current state, because with these 3 we know exactly what we need to do next, right? So, and this thing is basically, this one will return either true or false. It means that with the current state, basically with this many matchsticks remaining, with this sides and remaining sides remaining, and with this current side remaining, can we complete the entire square, right? If we have this kind of state here, now we can, because at the beginning, this thing will be 1 1 1 1, right? So basically the initial bit mask will be 1, and then the side will be 4, which means we have 4 sides to go, and the remaining, it will be the target, right? So that's going to be the initial DP state. So the next thing will be, how can we do the DP transition function here, right? So obviously from the current one, right, from the current state, how can we transit to the next state? So obviously is that we have to try all the possible sticks. I mean, all the available sticks, and we try to use that stick to form the current side, right? So form the current side, and there are some constraints, right? So first, if the stick, the length of stick is longer than the remaining, then the remaining of the current side, then we cannot use that stick, right? So which means we'll only pick the side who can be fit into the current side. And if that's the case, we're gonna update. First, we're gonna update this mask, which means if we choose to use that stick, this 1 will become to 0, and then the side and the remaining will also be updated, right? Based on if the remaining becomes to 0, and then that's when we need to do a side -1, right? And this, once this happens, right, and then it knows that okay, we have formed another side, which means this remaining will become to target again, right? Otherwise, if remaining is not 0, it means that side will be the same, and the remaining will be another remaining, will be updated. And then, so the base case will be when the side becomes to 0, right? This one becomes 0, and the mask also needs to become to 0, because because it says that we have to use each of the matchsticks exactly one time, right? So which means we need to check both of these two variables, because there could be a case that if we have many matchstick, but not all of them have been used, but we still have like side equals 0. That's also wrong. Cool. So I think that's the whole state transition function here. If we have figured that out, the implementation shouldn't be that hard, right? So first we have the total, right? So we need to calculate the target first, right? So we have a match sticks, okay, and then we do a simple check. So if the total cannot be divided by 4, then we return false, right? Otherwise we have target, so target will be the total divided by 4. Okay, and then we have n is going to be length of match sticks, okay, and then we simply return the dp of the initial state is this, right? That's the initial state, which is all 1, okay, and then we have 4 slides left, and we're working on the current side has target length remaining. Okay. So now the dp function, right? So we have the mask, we have the sides, remain, okay, and then we have current side remain, okay. I mean, the naming is always a pain. I'm trying to make this variable as clear as possible. So I think this one current side remain. This one is okay, but this one is this is the I'll just call it sides remain. Okay, whatever. Sides remain. Okay. And so the base case. So the base case is that whenever the sides remain it's 0, and the mask is also 0, right? So that's the two conditions we need to check for the base case, and then we return true because we know that's when we can be sure we have form like a square with all the matchsticks. Otherwise, the state transition, right? So basically, for each time we will loop through the each stick, and we'll try to find okay if this stick can be used to be part of the current side. So first we need to check if the current stick has not been used before, right? That's when we need to check if the current bit value is 1, right? So which means does not equal to 0 if the current stick has not been used. And then we check basically if the match stick current one is not greater than the remaining, right? I think there's an indentation issue here. The last thing we need to check is that if the and then we can just move to the next DP state here. So DP state will be the mask, right? So first we update this bit value from 1 to 0, right? So how can we flip that value, right? So there's a trick here. We do a XOR with this, and that's how we flip the value from either 1 to 0 or 0 to 1. I think I've already talked about this trick a few times, right? Basically, if we have 1 1 0 1 0, if you want to flip this one from 1 to 0, so what do? We do a bit white OR with this 1 1 0 1, right? So this will be 1 0 0 0, right? Okay, cool. So that's the mask, new mask. And regarding this new size remain here, there are like two conditions, right? So if the size, we still return the size if the matchstick is smaller than the remain, right? Else size -1, right? Basically, if this matchsticks equal to the remain, then it's the time. Yeah, actually, you know what? Let me do a little bit separation here so we can make this things a little bit clear. New remain. How about this one? So new remain will be remain subtract the matchstick, right? So right. So if the new remain still is not 0, then we still return the size. Otherwise, it means that this new remain is 0. Then it's time to reduce the size remain. Okay. So this one, so this is remain, right? This one will be the target, right? If not remain, right? Else remain, right? So that's the second part. Basically, if the new remain is equal to 0, then that's when we need to reset it back to the target. Okay. So for this one, basically, if this thing returns true, right? Then we know, okay, we have find a way to form a square. That's when we need to return true here, right? Otherwise, if none of the scenarios works, then we have no other choice but to return false in the end. Okay, and I think that's how it works. Cool. Yeah, so if I run the code, oh, invalid index, maybe here, double colon. Oh, I think I'm missing like a colon here. That's why. Current side remain. So this one, right? So this one works. Submit. Yeah, so it passed, right? Because so this is the time complexity equals to the number of states times the time complexity for each of the DP, right? So the number of states is like what? So we have 2 to the power of n different mask times the size remain. So this one is a constant. Basically, this one is 4, right? But the current side remaining, this is also Oh, actually, you know what? Actually, this current state remaining will not be a factor because, even though, because I was looking at this, oh my God, this one, the matchsticks will be 10 to the power of 9. Does it mean, okay, I have to times like 10 to the power of 9 here? That would be scary. But then I realized that actually this current site remaining will not be another factor here because, based on the mask here, right? So if we already know the mask, right? So we have the mask going to be something like this, right? If we have this mask here and we know the target, right? And if we know the target, let's say the target is 10, then we can calculate the current state remaining because because the current state means that we have already formed some side here, okay, and plus this side remaining, right? So let's say we have 2 side remainings, which means that we have already formed 2 side, right? So then it means that we have already used 20 like sticks, right? And also if we plus this bit mask, right, then we can calculate how many sticks we have used total, and then if we summarize the stick we have used and subtract the sides we have already formed, right? And then we know that what's going to be the remaining side, the current side remaining. What's the length we're working on right now? So actually, this one it's just like we don't have to pass this one in, but I'm just passing this one just to help me to calculate this next state uh, more easily, right? So that's why the time complexity will not be this. So it should be only 2 to the power of n plus times 4 maybe, but this one is a constant, so regardless, this one will not be a factor in this case. And so the remaining will be just like this for loop here, right? So the for loop is simply an n. That's why the total time complexity will be 2 to the power of n times n. And that's it, I think, right? Yeah, I think that's it, right? So I think it's not that difficult. It's simply, I think it's kind of classic top-down DP plus the mask, right? And then you just have to be able to find maybe another state variable and be able to try all the possible sticks, right? So that you can move to the next DP state. And cool. And thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.